For most of human history, we viewed space as a passive, empty stage, a simple three-dimensional grid that served as a vacuum for matter to exist within. This diagram represents that classical view, where space is merely a container. Albert Einstein changed that by proving gravity isn't a force that happens in space, but is actually the physical warping of space-time itself. In his model, mass tells space how to curve, and space tells mass how to move. Based on this, cosmologists expected the expansion of the universe to behave like a car coasting to a stop. They believed the collective gravity of every galaxy would act like a drag, slowly pulling the expansion back and eventually bringing it to a crawl. But in 1998, researchers discovered the opposite. By tracking distant light, they proved the expansion of the universe isn't slowing down, it's actually accelerating. It was as if that coasting car suddenly found a hidden engine and started gaining speed. To explain this acceleration, scientists created theoretical placeholders: dark matter, to provide extra gravity where we couldn't see any, and dark energy, to account for the mysterious outward push. The problem is the sheer scale of these placeholders. According to current math, these invisible substances must make up 96% of everything that exists, yet we have never been able to detect them directly. If we are missing nearly the entire contents of the universe, the error may not be in what we're looking for, but in our understanding of the void itself. We may be fundamentally misinterpreting the empty space between the stars. The big inflation theory proposes a different start. At the beginning of time, space itself, or dark energy, erupted as the first fundamental force, breaking free from the early universe's unified state. In this view, space is an active, outward-pushing force. It isn't just a vacuum. It is a relentless pressure that naturally expands faster than the speed of light, whenever it isn't pinned down by matter. This creates a constant war. Gravity pulls matter together, shrinking the fabric of space, while the vacuum exerts a relentless pressure to push everything apart. Think of a galaxy as a bubble, where gravity keeps the internal pressure fixed. Inside, gravity holds stars together. Outside, higher expanding pressure pushes inward, creating a gravity mound, a convex rim where space warps upward. Central gravity pulls these stars in, while the gravity mound provides an extra inward push. This explains why outer stars rotate as fast as inner ones without flying away, an effect previously blamed on dark matter. Under this model, dark matter isn't invisible particles, it is physical inward pressure. Space doesn't expand uniformly. Because the space inside a galaxy is locked by gravity, the adjacent void stretches aggressively into trapezoids, forming a pyramid shape between distant galaxies. These voids create a cosmic void lens. The angled walls bend the light path, magnifying the image like a glass lens. This means our current measurements of the universe might be warped. If these voids magnify distant stars, our calculations for the distance of supernovae and the true speed of expansion are likely skewed. To confirm this, we are using the James Webb Space Telescope to measure the rotation of ancient systems, checking if the push of space was weaker in the distant past. If the expansion of space has changed over time, then the geometry of the void is essentially a cosmic mirage, one that has significantly colored our understanding of both distance and the age of the stars. Today, we are seeing space regain the upper hand. As matter clumps further together and the voids between galaxies grow larger, gravity's reach becomes too thin to hold back the expansion, allowing space to resume its natural, accelerating speed. We can see signs of this even within our own neighborhood. The Pioneer anomaly was a mystery where spacecraft leaving our solar system decelerated more than expected. They weren't just slowing down due to the sun's pull, they were meeting an invisible resistance. This anomaly could be the first local evidence of a gravity mound. As the spacecraft left the heavy gravity of our planets, they began to encounter the upward push of the interstellar void, causing them to lose speed as if coasting up a hill. It suggests that what we experience as gravity is actually a net result. It is the inward pull of mass minus the outward pressure of the space it sits in. We don't notice this push in our daily lives because we live in an incredibly deep gravity well. The combined mass of the Earth, the Sun itself, and our galaxy effectively squashes the pressure of space, making its effect virtually negligible here. Ultimately, this theory reframes the void. Nothingness is not a lack of force, but a pressurized presence, an active counterweight to gravity that physically shapes every galaxy in the sky.